All right, everybody, welcome to Math with Grace. Today we're going to be going through Pre-Calculus, Unit 7, Section 2. Section 2 begins on page 36, and it's titled Complex Numbers. We've worked with complex numbers in the past. We're going to be working with them in polar form this time. So down here at the bottom, it says polar form of complex numbers. You should recall that the imaginary number I is defined as the square root of -1. Therefore, I squared is equal to -1. An example would be the square root of -9 is equal to 3i. The complex number system comprises the real numbers and the imaginary numbers. A plus bi is the expression, the form that we're going to use, where a is a real number and bi is the imaginary number. Here at the top of page 37, the horizontal axis is the real number axis, and the vertical axis is the imaginary number axis in the complex plane, okay? And points are plotted as a comma b. So a comma b. The complex number is placed in the polar plane. When a complex number is placed in the polar plane, we've got these formulas. Therefore, A, which remember is kind of like our x-axis, is equal to r times the cosine of theta. And B, which is our y pretty much, is equal to r times the sine of theta. Okay? R is called the modulus of the complex number, okay? And it's written like this, kind of like a vector, right? Theta is called the argument of the complex number, and theta is found as the opposite tangent of b over a. Very much like a vector, all right? Let's turn the page. The example here at the top of page 38, the first column says, express the square root of 3 minus I in polar form. Well, first we need to find r, which remember is the square root of a squared plus b squared. The square root of 3 is 3. The square root of not the square root. The square root of 3 squared is 3. The square root of 1, because the I is not included, and so -1 is what's sitting out here, right? So -1 squared is a positive 1. We add them together, that's a 4. You take the square root, which is then 2. So r is equal to 2, and then they solve for theta. So to figure out, it says, note that the square root of 3 minus 1 is in quadrant 4. And you might be thinking, what the heck? How would I know that? So if you think about plotting the point, the square root of 3 is going to be a positive number. So we would move this way. And this, remember, is a -1. So we would move down here. So it is in the fourth quadrant. Okay, if we were to plot that point, it would look like this. I'm not sure why we didn't do any plotting examples, but that's okay. If we were to plot that point, it would be right here, okay? Now, we need to find the inverse tangent of that. Now, they're doing a lot in this problem. Rather than just solving for the reference angle and then subtracting it from 360, they're doing it all in one go. And that's why the equation looks like this, okay? So they're taking the 360 minus the reference angle, okay? Remember, that's b over a. So 1 over the square root of 3. They simplified that square root of 3 because we can't have that in the denominator. And so we're looking for the angle that has a tangent of square root of 3 over 3, right? If we use our little chart, then we know that it's going to be pi over 6 or 30 degrees. Okay, so 30 degrees would be our reference angle. Subtracting that from 360 because we are, remember, in the third quadrant, okay, gives us a 330 degree angle. So now that we know that, remember, our A is equal to our cosine of theta, and our B is equal to our sine of theta. And so that's what they've done here. The 2, which is the R, just comes out front. They've factored it out, right? So it's out front, times the quantity, cosine of 330 degrees, because that's our theta, plus I sine of 330 degrees. Okay? And so that's the final answer in polar form. Let's look at this next example. Express 5i in polar form. Well, 5i, if you were to graph it, right, it would just be up here. It lies on the vertical axis, 5 units above the origin. So r is equal to 5. And it says here theta is equal to pi over 2. Again, you might be wondering, how do they know that? Well, again, if we look at our chart, remember, this is, if you look at your unit circle, right, it's 90 degrees. And the tangent of 90 degrees is pi over 2, right? This tangent down here is, not, the tangent isn't, the theta is, I'm sorry. Not the tangent of 90 degrees, but because it's 90 degrees, our theta is pi over 2. We don't want the degrees, although, I mean, technically we could use the degrees they did here. So I don't really know the difference between using the pi over 2 or the degrees. I assume you'll know by the given answers here. For those in my class, if it's one way or the other, I'm not going to mark it wrong, right? Okay, so theta is pi over 2 because it's on the vertical axis, all right? And again, writing the polar form is going to be r cosine pi over 2 plus I sine of pi over 2, okay? The last example in this part of section 2 says express 6 times the quantity cosine of 135 plus I sine of 135 in A plus B form. Okay, so now we're going from polar form to Cartesian form or rectangular form. We know that 6 is the R, and that's fine. We are first going to change this over, right, to our reference angle. Now, 135 degrees, right, is over here somewhere. So in that quadrant 2, cosine is negative. So it's going to be the negative cosine of 45 degrees, our reference angle, plus I sine of 45 degrees. Looking at our unit circle, scooch it over here, okay? The cosine of 45 degrees is the square root of 2 over 2. So negative square root of 2 over 2. The sine of 45 degrees is the square root of 2 over 2, okay? And so they have multiplied. Once they have that set up, we have to distribute this 6, okay? When they distribute that 6, we get negative 3 times the square root of 2 plus 3 times the square root of 2i. I would have written it 3i times the square root of 2, personally. I don't like the I looking like it's underneath the radical sign, so I like to put it out front. That's a personal choice of mine, okay? All right, let's do some of these problems together. Taking a look here at number 4. If z equals the square root of 5 minus the square root of 2i, then absolute value of z, remember that's like the magnitude. Remember we were talking about vectors, and okay? So the magnitude of z. Well, remember, z, or my brain's going too fast. So the magnitude of z is going to be equal to r squared, which is equal to the square root, or it's going to be equal to r, sorry, which is equal to the square root of a squared plus b squared. Okay, so that's all we have to do, this part here. A is the square root of 5, and b is negative square root of 2. So the square root of the square root of 5, the quantity squared, plus the square root of, negative square root of 2, the quantity squared. Well, the square root of 5 is 25. It's 5. Oh my gosh, it's 5. It is that kind of day. Okay, the square root of 5 squared is 5. The negative square root of 2, the quantity squared, is 2. So 5 plus 2, okay, goodness gracious, is equal to the square root of 7, right? So letter B. All right, let's take a look at another one, number 5. What is the modulus of 5 plus 3i? Now, this is the same question. It's still this, okay? So we are going to take the square root of 5, the quantity squared, plus 3, the quantity squared, right? Which is going to be the square root of 25 plus 9, which is going to be equal to the square root of 34. Now, the square root of 34 can't be reduced. None of these examples they give us can, I suppose. So the answer is C. Okay, let's see here. Let's take a look at number 7 real quick. What is the argument of -1 plus the square root of 3i? Remember, the argument is theta. And when we're solving for theta, we're going to take the tangent reverse of b over a, or the square root of 3 over -1, okay, because this is a negative. And that's going to give us the tangent of what? Negative square root of 3. So going to our chart, okay? Here's our square root of 3. It's at 60 degrees. So this is saying negative 60 degrees. Think about where this point is, okay? It's at -1 here, right? It's there. Our tangent is going to be negative. But if our reference angle here is 60 degrees, then what is the actual angle? Well, it's going to be, so this was 60 degrees, it's going to be 180 minus 60, right? Or 120 degrees, okay? So remember, the argument is theta. All right, let's take a look at number 10. It says here, express -9i in polar form. So it's very similar to this example that we did right here, right? First thing I want to do is look at where is -9i. Well, -9i is going to be way down here, okay? So now we need to go about the rest. The r is going to be 9. All right, so it's definitely not this one or this one. It's going to be one of these two. Now, this axis is the 270 degree axis, right? Or 3 pi over 2. Now they're using the radians, so we're going to use the radians, right? So it's going to be 9. I mean, you can already see the answer, right? It's going to be 9 times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2, okay, which is letter D. Okay, so these ones on the axis, you just need to look and see. The axis, writing 270, they think, I guess, maybe would be too easy. But honestly, writing 3 pi over 2 is not any harder. It's the same exact representation. Okay, let's look at number 11. Express -2 times the square root of 2 minus 2 times the square root of 2i in polar form. Okay, I'm going to draw my point because I want to see where it's at. I'm going to be at -2 times the square root of 2 minus 2 times the square root of 2. It's going to be down here, third quadrant, okay? Okay, since we have that decided, let's figure out the r. Remember, r is going to be equal to the square root of a squared plus b squared. So, -2 times the square root of 2 squared plus -2 times the square root of 2, the quantity squared, okay? -2 times the square root of 2 squared, we square the -2, which gives us 4, and we square the square root of 2, which gives me 2. So 4 times 2 is 8, and then the same is going to be here, 8, right? which is the square root of 16, which is equal to 4. So r equals 4. Okay. Now, if you didn't have multiple choice, like if you were taking one of my quizzes, right, you wouldn't have multiple choice. So, but for now, we can cross off those two because we know that 4 is the r. All right. Now we need to figure out the theta. Okay. Well, remember, it's going to be the tangent of b over a. Okay. So, inverse tangent of b over a, b is negative 2 times the square root of 2, and a is 2 times the square root of 2, okay? So it's the inverse tangent of negative 1. All right, let's look at our chart. Here's a 1, and so it's pi over 4. Now it's negative because, remember, of our, where's our space here? Actually, I think that's positive there. All students take calculus, right? So it would, tangent actually would be a positive, but it's still 45-degree reference angle, okay? Here's our 1, 45-degree reference, or pi over 4. Here they're using degrees, so it's a 45-degree reference angle. So how do we figure out in quadrant 3 what our actual angle is? Okay, well, our actual angle is going to be 180 plus 45. Okay. Okay, and I just noticed this is a negative 2. I forgot. They're both negative, so this would actually be a positive 1. Okay. But we're adding, right? And so that is going to be 225 degrees, right? So if you didn't have the multiple choice, right, your answer would be 4 times the quantity cosine of 225 degrees plus I times the sine of 225 degrees, right? Which is letter C. All right? Okay, go ahead and finish the few problems here that we didn't do together and meet me back here for the next part of this section. The next part of section 2 begins on page 40, and it's titled Multiply and Divide Complex Numbers. It says multiplication in polar form is what we're going to be looking at first, and they go through how it is derived. The formula for finding the product of two complex numbers in polar form is here, okay? R1, R sub 1 times R sub 2 times the quantity of the cosine of the thetas added together, right, the two angle measures, plus I times the sine of the two angle measures. So let's look at that example here at the top of page 41. If find z sub 1 times z sub 2, if z sub 1 is equal to 3 times the quantity cosine of 50 degrees plus I sine of 50, and z sub 2 is equal to the cosine of 70 plus I times the sine of 70. Okay, well, we're going to take r sub 1 plus or times r sub 2. R sub 1 is 3. R sub 2 is just 1 because it's not shown, right? So there's my 1. And then we have the cosine of 50 plus 70 plus I times the sine of 50 plus 70. Okay, that's 120 degrees each. Obviously, it's going to be the same. We're adding 50 and 70 in both cases. And so there's the answer. So 3 times the quantity cosine of 120 plus I times the sine of 120. All right. This next example says, find the product of the 2 times the quantity cosine 1 or pi over 4 plus I sine pi over 4 and 4 times the quantity cosine pi over 2 plus I sine pi over 2. Express the answer in a plus bi form. So we need to pay attention to what form they're asking for, right? Here they didn't ask for a form in particular. They just wanted you to solve. So this is enough, okay? But here they want it in a plus bi form, so we have to go that extra mile. So to start out, we're going to multiply our r's. So 2 times 4 is 8, right? Then we're going to add pi over 4 plus pi over 2. Remember, when adding fractions, I'll do it right here. Pi over 4 plus pi over 2, right? They have to have a common denominator. That common denominator is going to be the 4. So pi over 4 plus 2 pi over 4 because that would reduce back down to here, right? Gives me 3 pi over 4. Okay, so 8 times the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. Using their unit circle, right? We are going to locate 3 pi over 4, which is here. Okay, 3 pi over 4. The cosine of 3 pi over 4 is negative square root of 2 over 2. The sine of 3 pi over 4 is the square root of 2 over 2. Distribute your 8, okay, and you end up with negative 4 times the square root of 2 plus 4i times the square root of 2. All right? Okay, that's multiplication. Division, now again, they go through how they derived the formula, but at the top of the second column on page 41, the formula is here. So the formula for finding the quotient of two complex number in polar form is this. R sub 1 divided by R sub 2 times the quantity cosine of the first part, the R sub 1 or the Z sub 1, minus the Z sub 2, plus I times the sine of 1 minus 2, angle 1 minus angle 2, okay? Let's look at this example. Find Z sub 1 divided by Z sub 2 if Z sub 1 is equal to 10 times the cosine of 190 plus I times the sine of 190. And Z sub 2 is 5 times the cosine, times the quantity, cosine 40 degrees, plus I times the sine of 40 degrees. Express the quotient in A plus B form. So we want to go all the way, right? So R sub 1 divided by R sub 2 is 10 divided by 5, or 2. And then the theta, and then, I forget what this is. Is that phi or something? So it's going to be Z sub 1's angle measure minus Z sub 2's angle measure, okay? Which gives us 150 degrees. Again, with our unit circle, 150 degrees. The cosine is negative square root of 3 over 2. The sine is 1/2. Distributing our 2 throughout gives us negative square root of 3 plus I. On to the next one. It says find Z sub 1 divided by Z sub 2 if Z sub 1 is equal to 3 times the quantity cosine pi over 2 plus I sine pi over 2. And Z sub 2 is equal to 6 times the quantity cosine pi over 6 plus I pi over 6. State the modulus and the argument. So they want a couple of different things here, right? First, we need to figure out, they want us to find this, and then they want us to state the modulus and the argument, okay? So R sub 1 divided by R sub 2 is 3 divided by 6, or 1/2, okay? Pi over 2 minus pi over 6, okay? I'm going to work it out for you. For those of you, some people have a hard time with fractions, right? So pi over 2 minus pi over 6, okay? Common denominator needs to be formed, and that's going to be 6. So I have to multiply this one by 3. So 3 pi over 6 minus pi over 6 is going to be 2 pi over 6, right? Or pi over 3, because we need to reduce our fractions. So we end up with 1/2 times the quantity cosine pi over 3 plus I sine pi over 3. That's our Z sub 1 divided by Z sub 2. That's the first part of this equation. They want us to state the modulus. Remember, the modulus is just the R. And in this case, our R, the R, ended up being 1/2. Okay? The argument is just the theta, and that is pi over 3. Okay, so in solving this, we really did answer these two things, but they wanted us to state them separately, and so there they are. All right, let's turn the page. There's one more example here at the top of page 42, and then we'll do some problems together. It says find Z sub 1 divided by Z sub 2 if Z sub 1 is equal to 1/2 times the quantity cosine pi over 4 plus I sine pi over 4, and Z sub 2 is equal to 2/5 times the quantity cosine 135 degrees plus I sine of 135 degrees. Express your results in A, B form. Okay. R sub 1 divided by R sub 2 they're both fractions. We can't divide a fraction by another fraction, so we're going to multiply by the reciprocal. The reciprocal of 2/5 is 5/2, right? So 1/2 times 5/2 is 5/4. Okay. Now, in the original problems, we had radians and degrees. So first things first is we're going to change our pi over 4 into degrees because that's going to be easier to work with. If you look at your unit circle, pi over 4 is the same as 45 degrees. So that's what they've done. 45 minus 135, which gave us a negative 90 degrees. Okay. The cosine of 90 degrees is 0. The sine of 90 degrees is 1. So we have a 0 and a negative 1 because it was negative, right? And then we distribute our 5 over 4. Obviously, the 0 just disappears because there's nothing there. And so the answer is negative 5/4 I. And you're done. All right, let's look at some of these problems together. Problem number 13 says find the product of z sub 1 equals 8 times the quantity cosine 20 plus I sine of 20, and z sub 2, which is equal to 2 times the cosine of 40 plus I sine of 40. Okay, so they want us to solve for z sub 1 times z sub 2. So that is going to be equal to 8 times 2 times the quantity cosine of 20 degrees plus 40 degrees plus I times the sine of 20 degrees plus 40 degrees. 2 times 8 is 16. So 16 times the cosine of 60 degrees plus I sine of 60 degrees. Okay? There, we're done. And it is this one, letter C. Okay? Let's look at number 14. Z sub 1 is equal to 3 times the quantity cosine 2 pi over 3 plus I sine 2 pi over 3. And z sub 2 is equal to 4 times the quantity cosine pi over 6 plus I sine pi over 6. Then the argument of z sub 1 times z sub 2 is what? Well, honestly, we don't really need to add the or do all the multiplying. They only want the argument. Okay? The argument is going to be 2 pi over 3 plus plus pi over 6. Now, they have to have a common denominator, which is going to be 6. So I'm going to multiply the numerator and the denominator by 6, or by 2. So 4 pi over 6 plus pi over 6 is going to give me 5 pi over 6 is my argument, which is letter D. Let's take a look at problem number 18 over here on page 43. If z sub 1 is equal to 6 times the quantity cosine 3 pi over 2 plus I sine 3 pi over 2, and z sub 2 is equal to 2 times the cosine 5 pi over 6 plus I pi over 6, or plus I times the sine of 5 pi over 6, then the argument, so now we're dividing, right? And there's not a lot of space here, but I'm going to kind of work a little bit above, right? But really, again, they only want the argument. So they don't want the whole problem. They really just want the argument. So let's take a look at how we would find that. Well, it's going to be 3 pi over 2 minus 5 pi over 6. Okay? A common denominator is going to be 6. So this is going to be 9 pi over 6 because I had to multiply both the top and the bottom by 3, minus 5 pi over 6, which is going to give me 4 pi over 6, or 2 pi over 3, because we want to reduce our fractions. 2 pi over 3 is letter A, and that is our answer. Okay. Number 19, find the quotient of 3 times the quantity cosine 135 plus I sine 135, and 9 times the quantity cosine 45 plus I sine of 45. Now, here they want the quotient. We got to work out the whole problem, right? So this is going to be 3 divided by 9, okay, times the quantity cosine 135 minus 45 plus I times the sine of 135 minus 45, okay? Didn't quite fit on there. All right, so I have 1/3 times cosine of, what is this, 90 degrees, plus I times the sine of 90 degrees. Okay, now I need to figure out, they're not actually giving me, they didn't say like form AB, but that is what is happening here, because if you look, I've got some I's, I've got some just numbers, so it's in a form AB. So we need to go the next step, right? What is the cosine and the sine of 90? So 1/3 times, grabbing my unit circle, here's 90. The cosine of 90 is 0. Plus I times the sine of 90, which is 1. Okay? So distributing our 1/3 is going to just give me 1/3 I, which is right here, letter C. All right? Okay. I'm going to let you go ahead and finish the rest of these problems on your own. Of course, if you have a question, let me know. I'm happy to help. But go ahead and finish these and meet me back here for the final part of this section. The final part of this section begins here on page 44, and it's titled Powers and Nth Roots. Okay, powers. The rule for multiplying two complex numbers is this. Okay, we just did this on the section right before here, the part right before here, right? It says for a complex number in polar form, then, if we are taking it to a power, right? The whole thing, r times the quantity cosine theta plus I sine theta to the nth power would be the same as r to the n times the cosine of n times theta plus I sine of n times theta. Okay, so that's how we would take it to the power. So looking here at this example, if we have the quantity 2 times the quantity 2, or cosine 20 degrees plus I sine of 20 degrees, all of that raised to the third power, and they want us to express it in a plus bi form, then we're going to take our given thing, we're going to cube, because that's what we're cubing here, cube the r, and then we're going to take cosine of 3 times 20 degrees plus I sine of 3 times 20 degrees. So we have 8, because 2 cubed is 8, cosine of 60 plus I sine of 60. We're going to use our unit circle, okay, and find our 60 degrees and see that the cosine is 1/2 and the sine is square root of 3 over 2. Distribute our 8 and end up with 4 plus 4 times the square root of 4i times the square root of 3, right? They keep going back and forth on how they write this. That to me is a clearer answer. All right. This next example, they want us to simplify the quantity 2 minus 2i to the 4th power. First things first, we need to write it in polar form. So they solve for their r, which is 2 times the square root of 2. And then they solve for their theta, which is 315 degrees. Now remember, you have to think about where this is plotted, positive 2, negative 2, which is over here, 4th quadrant. So we are going to be finding a reference angle and subtracting that from 360 degrees, and we got our 315. So this is the polar form. Now that it's in polar form, we can take it to the power of 4, okay? Which is going to be 2 times the square root of 2 raised to the 4th power times the quantity of the cosine of 4 times 315 degrees plus I times the sine of 4 times 315 degrees, okay? 2 times the square root of 2 to the 4th power, okay? Remember, we're taking it to the power, but we've got two things. We have 2 to the 4th power, and we have the square root of 2 to the 4th power, okay? 2 to the 4th power is 16. The square root of 2 to the 4th power, you got to kind of think of it like this. The square root of 2 times the square root of 2 times the square root of 2 times the square root of 2, right? What it's going to give you is 4. All right? So 16 times 4 is 64. All right? 4 times 315 is 1,260. Now, you've got to figure out what is that reference angle, okay? How many, you're going to divide it by 360, right? And how we've done that in the past. And they figured out the reference angle is 180 degrees. Then they used a unit circle to find the cosine of 180 degrees is -1, and the sine is 0. So the answer was -64. Okay, so that's the powers part of all this. Let's take a look at the roots. On this page here, page 45, we're talking about the roots. Now, here is all how they derived it, okay? There's quite a bit going on here. Right, to summarize, okay? If we have r sub 1 cosine of theta plus I sine of theta to the nth power, so just like we were doing over here, right? We change that so that we have r to the nth. Well, r sub 2 is representing r to the nth power, okay? We're distributing basically our power. And then the cosine is now going to be n times theta, which is now this symbol. And the sine is the same thing. N times theta is now this symbol. Okay, so that's how the symbols line up in this problem. I'm going to rewrite that here in 1 second. I guess there's no point in rewriting the whole thing, so because it's basically just this. But let's see. R sub 2 is equal to R sub 1 to that nth power. Okay, so that's one note that you need to think about. And this symbol is equal to n times theta. Those are the two things you need to keep in mind when looking at these, okay? So r sub 1 is going to be equal to the nth root of r sub 2, okay? Which makes sense because r sub 1 to the nth power is r sub 2. So, of course, r sub 1 would be equal to the nth root of r sub 2. Okay, it's kind of like we're just reversing what we did. Theta is going to equal sideways theta. I should look up what that means, but I don't. It's not going to help me right this minute. Okay. Over n, which remember is our power that we're raising it to, plus 2k. Now, so you might be wondering, well, what the heck is this k? We'll get to that in a second. 2k pi over, again, the power. And here's how our k works, okay? Our k is kind of like a countdown. We can only have a number of roots equal to the n minus 1, right? So k is equal to, it's always going to start at 0. We're going to have multiple steps here because remember, roots, there's always multiple roots. Not always, but usually there's more than one root, right? So k is going to start at 0. And then it's going to go to 1, 2, 3, 4, 5, up until we get to the power minus 1. All right? So in this next example here, we have z squared. So my k's that I'm going to be using here are k equals 0 and 1. That's it. But that's the two roots that we need, right? Remember, just like when we were factoring in algebra, right? If there's a square, then we have 2 roots. If there's a cube, then there's 3 roots, so on and so forth. Same thing here, but the k starts at 0 and goes until n minus 1. So n minus 1, 2 minus 1 is 1. So those are the 2 k's that we're going to be using to solve with. All right, so keep this in mind. Let's take a look at this example. I'll try to keep it all on the page. I know these pages are kind of long, so, and I try to get as close as I can because I know, anyway, you guys are watching on phones or whatever, it's hard to see. But let's take a look at this. Find all the solutions or the roots of z squared equals I, okay? Z represents a complex number, right? So we can rewrite this complex number and write it in polar form. So writing this in polar form, remember I is on the axis up here, 90 degrees, right? So that's where how they have the cosine of 90 plus I sine of 90, right? Because that's where I lands. Now, the 1 they've just put out front because it's there, right? We don't have any other number, but the 1, it's always going to have a 1, right? So what is the r? Well, remember down here, okay? R is going to be equal to the nth root of r squared. R squared is the same as the z squared, which is 1. Okay, so the n in this case is equal to 2. I'm just going to write it right here. K is 0, 1, n is equal to 2. So we have the second root, or the square root of 1, to be our r. Okay, so we found the r. Now we need to find our thetas. Okay, we're going to use this formula right here with our different k's. So 90 degrees divided by 2, because that's our n, plus 2 times 0, because that's my k, times pi, in this case, 180 degrees over 2. Doesn't matter, all of this disappears because it's times 0, so 90 divided by 2 is 45 degrees. All right? Now, the next k, that was the first k, now we need to do the second one. 90 degrees divided by 2 plus 2 times 1 times 180 over 2 equals 45 degrees. Plus 180 is 225 degrees. So the solutions of z squared I are 1 times the quantity cosine 45 plus I sine of 45, and 1 times the quantity cosine 225 I sine 225. To put the solutions in a plus b form, we would then use our unit circle, right, and find the cosine and the sine of 45 and the cosine and the sine of 225, and distribute our 1, but of course it's a 1, so that's whatever. Then it says we can check our solutions by squaring each to see if in fact they do equal I. So kind of like a test your work kind of thing. You can square it and see, does it actually equal I? Yes, it does. Your answer is correct. All right. So it's a little bit complicated. We just have to follow the formula. So real quick, I want to cover, right, before we go on to the next example, some of you might be thinking, I still don't understand where this 180 came in. In this box right here, it's a reminder, but it says, remember that 2 pi is equal to 360 degrees. So 1 pi, which is what we're calling, I mean, the 2 is here. They could have written, instead of writing this 2 and this 180, they could have just written 360 here. But they decided to keep this 2, so we needed 1 pi. So half of 2 pi is 1 pi, so half of 360 is 180, and that's where that 180 comes in. So before we move on, I want to just make that clear. Let's turn the page. One more thing before we turn the page as well. I said that this symbol, right, the sideways theta, whatever it is, phi, delta, I don't really know, is equal to n times regular theta. If we solve for theta by dividing both sides by n, then we get theta is equal to omega, whatever this is. Is that omega, right? And did I get it right for the first time? Divided by n. That's where this comes in, okay? So it's really just theta divided by n. And that's why this was 90 divided by 2, right? Not 90 times, I mean, even if it was 90 times 1, it would still be 90, right? But that's where we just get 90 divided by 2 from. All right, I'm just trying to be super clear looking over these points before we go forward. I want to make sure you understand all the different parts of this formula. Okay, let's turn the page for real this time. All right, so at the top of page 46, we have this example, and I started working it out a little bit, and then I wanted to go back and clarify, so that's why we went back again to the page before this. But they want us to find the fourth roots of negative 16. So my n is 4. My k is going to be 0, 1, 2, and 3. And here is my negative 16 on a coordinate plane just for reference sake. So writing it in polar form, I have 16 times the quantity cosine of 180 plus I sine of 180. Because remember, that axis is the 180-degree axis, okay? Here are the formulas here. I don't want to block them, and I don't want to have to rewrite them because they're just right there. So let me move my paper here. So we are going to be setting this up for all of the different bits, right? So the first part is going to be our theta over n. N is 4, plus 2 times k, which is 0, times 180 degrees, which is pi, right? Divided by n, which is 4. This part cancels out because it's got the 0, 45 degrees, right? Next, 180 over 4. They're all going to start with that 180 over 4, right? Plus 2 times 1 times 180 divided by 4. So it's going to be 45 plus 90, or 135. The next one is the 2. So it's 45 plus 180, 225. And the next one is 3, 45 plus 270, 315. They've plotted them all, which is great. But we need to find what the actual roots are. So we need to finish this problem. And to finish the problem, we need our unit circle. Because what is the cosine of 45 and the sine of 45? Distribute our 2 and get our answer. What is the cosine of 135 and the sine of 135? Distribute our 2 and get our answer. What is the cosine of 225 and the sine of 225? Distribute our 2 and get our answers. And so same for 315, okay? Distribute our 2 and get the answer. Those are the roots. These are the roots of the problem, okay? Now it says up here, the fifth root of negative 16 would be these, because instead of dividing by 4, we would be dividing by 5. And so it would be a little bit off, right? Now it states here that you would still begin at 45 degrees, but that is not a true statement, okay? Because this would still be divided by 5, and 180 divided by 5 is 36 degrees. So this is not correct, okay? You would actually be beginning at 36 degrees, because if you didn't, then these wouldn't be evenly spaced, and it's not how that works, okay? These are all evenly spaced, and so no, you don't get, you wouldn't start at 45. Okay, so it's a bit of a mistake here in the book. It happens. It happens to me all the time. I'm sure it happens to you. Mistakes happen. Okay, example, this next one. Find the 3 roots of unity in a plus b form. Okay. Unity meaning the origin, I believe, which is why we have cosine 0, sine of 0. And therefore, we would have 0, and then, right, 0, 0, and then it has 120, because we're dividing by 3, right? 360 divided by 120, or 360 divided by 3 is 120, so that is the spacing for our points, and so then they use those to find their, this is kind of an interesting problem, but I wish they had just given us another one of these to practice with. But we'll do some of these together, and that will be our practice, okay? But basically, whatever your n, right, 3 roots, 4, 5, if you divide that by 360 by n, you would get the spacing. So if I'm starting at 0, my spacing is 120, and then every 120 degrees would be a point, right? Which is why this one's a little bit wrong, because 360 divided by 5 is not going to start me at 45 degrees. Okay? All right. Let's do some of these problems together and practice together. Now, remember this, the Let's Review has some of our formulas that we're going to need, so that's great. So they want us to find this quantity cubed. 4 times the quantity cosine 15 plus I sine of 15, all of that cubed and expressed in a plus bi form. Well, remember, here is what we're going to be working with, okay? So we are going to have 4 to the third power times the cosine of 3 times 15 plus I times the sine of 3 times 15. Oof. Okay, so 4 cubed, 4 times 4, 16. 16 times 4 is 64. Times the cosine of 3 15s is 45. Plus I sine of 45. Now, they want us to express it in AB form, so we're going to need to grab our unit circle, getting a lot of use out of that today, because we need the cosine and the sine of 45. So I have 64 times the cosine, or I don't, not times the cosine, but the cosine of 45 is the square root of 2 over 2, plus I times the square root of 2 over 2 for the sine. All right. Distributing our 64 is basically taking 64 divided by 2, right? So I have 32 times the square root of 2 plus 32I times the square root of 2. All right, which is letter C. Okay. They want us to simplify 1 plus I to the 8th power. Well, to do this, first we need to get this into polar form, okay? So R is going to equal the square root of 1 squared plus 1 squared, okay? Which is basically the square root of 2. After that, we need to solve for our theta, right? Which is the inverse tangent of b over a, which is 1 over 1. The tangent of 1 is 45 degrees. I think that's okay to use 45 degrees or pi over 4. Let's just leave it with 45 degrees for now. So we end up with the square root of 2 times the cosine of 45 degrees plus I times the sine of 45 degrees. Okay, that's our polar form. And now we're going to take all of that to the 8th power. Okay, so I'm going to have the square root of 2 to the 8th power times the cosine of 8 times 45 degrees plus I times the sine of 8 times 45 degrees. Okay. Now remember, the square root of 2 to the 8th power is 8 square roots of 2's. 4 of those then will become 2. And so it's 2 times 2 times 2 times 2, right? 4, 8, 16. So 16 times the cosine of 8 times 45, which is 360 degrees, plus I sine of 360 degrees, okay? Pulling out our unit circle. 16 times the cosine of 360, which is 1. Oh, I don't want to close my parentheses just yet. Oh, my eraser is getting funky. 1 plus I times the sine of 360, which is 0. Okay, so this part is gone away. 16 times 1 is 16. The answer is letter C. Okay, let's turn the page and do a couple more. If it were up to me, you would need to do number 27, where it's asking you to explain. You can do it if you like, I guess. I'm going to take a look here at problem number 29. Which of the following options best represents the modulus of the 5th roots of square root of 5 plus 2i? Well, to figure out the modulus, first we need to figure out the r, right? And so r is going to equal the square root of the square root of 5 squared plus the square root of 2, or not square root of 2, but just 2 squared, okay? So this is our 5, the square root of 5 plus 4, which is equal to the square root of 9. So my r is equal to 3. Now remember, the modulus is the nth root of r. And so our n is going to be 5 because we're looking for the fifth root. So the fifth root of 3, the square root of 3, sorry, a. Because, yeah, remember, it's going to be the nth root of r. Okay, so r is 3. The nth root is 5, so the fifth root of 3 is letter A. Okay? Right. Now, which of the following, let's do number 30, is a solution to z to the fifth equals 1 plus the square root of 3i, or I times the square root of 3. First, let's transfer it to polar form, right? So r is going to equal the square root of 1 squared plus the square root of 3 squared, okay? Or the square root of 1 plus 3, square root of 4, 2. First part done. Now, my theta is going to be equal to the inverse tangent of b over a, or the square root of 3 over 1. So theta is square root of 3, which is 60 degrees. Okay? Now, it's asking which of these solutions is a possible root, so we need to figure out the different parts of our k and whatnot now, right? So our n is equal to 5, so my k is going to be 0, 1, 2, 3, and 4. Those are my k's. I don't really want to do the whole problem, right? We're not going to rewrite it every time, but we are going to do each piece because we got to figure out what. So I'm going to have my k equals 0 is going to be 60 degrees divided by, where's my n? Over here, 5. Okay, plus, all right, so I got a random blocked phone call that messed up my recording. And so I was at 60 degrees divided by 5 plus, and I actually did it all already and it wasn't recorded. So we're just going to walk through it again. So plus, remember the equation, 2 times k times 180 divided by n, right? This one doesn't matter because it has the 0 in it. 60 divided by 5 is 12 degrees. So that's our starting point. Like if we were plotting these, right, on our polar circle, 12 degrees would be our starting point. So then my next thought is, because I want these problems to be as simple to complete as possible, is, well, 360 degrees divided by 5, because remember, the points are all going to be equidistant from each other, is 72 degrees. So starting at 12, every 72 degrees, there's going to be a point. That's how this works. So I sat here and did the math. 12, where we started, plus 72, the next point is at 84 degrees. 84 degrees plus 72, the next point is at 156, which is our actual answer, B. But just to make sure there wasn't multiple answers, I continued. 156 plus 72, the next point is at 228. And 228 plus 72 puts the next point at 300 degrees. Remember, they're all equidistant from each other on the polar graph. To me, this is a much more direct and less complicated and less places to make a mistake, right? Than having to rewrite this equation every single time. So it's kind of a cheater way to do it, but that's fine. Writing it back in this form, of course, we have to remember that the r is 2. So in the beginning here, we have the nth root of 2, and we have 5. So it's the fifth root of 2, which is why that's in the front. And then we have the cosine of 156 plus I times the sine of 156. Okay, so that is how I solved this one. I feel like this is a much easier way. Less mistakes will be made if we do the problem this way than writing out this formula a bunch of times. All right? Okay. That is it. Go ahead and finish the rest of these problems. That's it, though, for section 2 and actually for book 7 as a whole. As always, if something comes up and you have a question, please don't hesitate to contact me. Otherwise, until next time.